This is the exam one review for Stat 417. And I gave a little bit of an overview of the topics in class the other day, but this is a little bit more detail, a little bit about strategies and a little bit about differentiating different types of problems. So I mentioned the median quartiles. What I mean by that is we're finding the median and quartiles for really small data sets, like 10 values or something. So you can do it by hand. Just remember that the first thing is the median, and then the lower half of the data has a median, which is the first quartile, and the upper half of the data has a median, which is the third quartile. There is no fourth quartile, and the second quartile is the median. So that's part of it. The marginal distribution is so I call it a contingency table, and the textbook calls it a two-way table. That means the same thing. It's just they're talking about a two-variable table with the values, the counts in each of the boxes of the table. So actually, the contingency table is the table. The marginal distribution is something you can do with it, like in the homework problem. The scatter plot is the graphical display of a data set with two variables. Scatter plot is the picture, and regression line. So that'll be a y equals mx plus b. A line that's also called the least squares line for historical reasons. But so this is kind of one topic. It's a couple problems on one of each on the exam, but making the scatter plot, and then you'll use your calculator to find the coefficients of the regression line, the slope and the intercept. The discrete probability model. So this is a discrete situation. As a discrete variable, it can only have certain quantities, certain outcomes, not a continuous variable where it's a real number. So this is the kind of thing we see in a table. And the table gives the outcomes and the corresponding probabilities. And we can do things like that. We can do things with it, like calculate probabilities of a compound event, more than one of the outcomes. Or we can calculate the expected value, or the mean value. The 68, 95, 99.7 rule, or the empirical rule is the other name for it. So that was the one about going certain, in a normal distribution, going certain numbers of standard deviations to either side. And this is one standard deviation to each side, two standard deviations to each side, and three standard deviations to each side. And you can actually use that to calculate not a lot of things, but if the probabilities you're looking at are these, it's very quick. Okay, so that's the overview of most of the exam. There's another part that we have to make a distinction between the two different ways that we use the normal probability. So the normal distribution probability is the situation where we're we're talking about an x value, a data value. And the thing we use in calculation is the standard deviation. You can use the symbol would be normally distributed with a mean mu and a standard deviation sigma. To actually calculate a probability, like the probability that x is greater than, just going to make something up, 3, that's where we use the normal CDF function. I'm running out of room, but the input for the CDF function, so greater than 3, that means 3 would be my lower bound. My upper bound would be infinity, but 10 to the 99 power is big enough for a calculator. And then whatever the mean and standard deviation are, you put those in as inputs, and that gives you a probability for a normally distributed variable. Sampling distribution, probability. So if we want to do sampling distribution, it's also normal, but in this case we're not talking about values of the data, it's values of the sample means. So there's associated with this a sample size n, and where that n becomes really important is, instead of using a standard deviation sigma in our calculation, we're going to use that sigma x bar, which is just sigma divided by the square root of n. And the difference between these is context. We use the same function, normal CDF, to do this. You use a different standard deviation, but everything else would be the same. And you would answer questions like, what's the probability that the sample mean is greater than 3, rather than the x data value. Oh, that's glary. That top one is a x greater than 3 probability. The bottom one is x bar greater than 3. And that's a pretty big difference, because here we're talking about 1, and here we're talking about n individuals. Keeping these two separate is one of the tricky things, because we are doing the same thing. We're doing the normal CDF function. It's just the context is different, individual versus sample. And that's what I've got. All these concepts are illustrated in the homework problem. So if you go back through the chapters that have those topics and look at those problems, that'll kind of narrow your focus on study. And here's Aqua. She doesn't know what's going on. But Aqua's my fluffy, tailless cat creature. I'll see you on Friday.